Welcome to PyData Global 2021, and triple thanks to Adam for being a speaker here. And since it is time, I'll let him take over.
Okay, thank you very much. Okay, so yeah, today I'm going to be talking about how we go about building data-driven products at Blue Yonder. And I'm a data scientist myself, so I'll be talking about it from the perspective of a data scientist. I'm sure there are various aspects of product development that are not related to data science at all, which I won't be touching on. So the data-centric aspects of it. And yeah, I'll just get started. Okay, so only got 25 minutes, so it's a fairly simple plan. First of all, a few introductions, just so you know who I am and who the company is, Blue Yonder. And then I'll introduce the idea that we're currently developing or hoping will become a product. A little bit about our tech stack, which is obviously going to dictate a little bit how we go about things. And then finally, I'll walk through the timeline of a development. So again, using this current example to walk through. Okay, so first of all, yeah, who are we? My background personally is in particle physics. I joined Blue Yonder after doing my PhD back in 2014. And the company at the time, it's a small German company, had a similar background. So it was founded by a particle physics professor who saw a good opportunity to apply statistical methods from particle physics into real world business problems. And he also had a good pool of PhD students to hire as his first people to bring into the company. And so it was a very easy transition for me personally to move into the company for that reason. It was unusual in that it had more than half of the company was made up of PhD students, or old PhD students who had moved into business. And the idea of behind the company was basically to go find customers, get them to send us their data, and just see if we could predict something useful from it. So we had no product development background. We were just basically a bunch of nerds who thought, let's see if we can do something a bit differently to how it's been done in this industry before. And so we had some success with that. Eventually we had a few customers, but very bespoke solutions for those customers. And realized that in order to scale, we're going to need to start productizing what it is we do. And after numerous years, lots of failures, very inefficient route to it, we had a few quite well developed products. So demand forecasting products, some around order optimization, some for price optimization. This was kind of our sweet spot. And at that point, we were acquired by JDA in 2018. Who had solutions much more across the full supply chain. So they went back into transportation, logistics, warehouse management, all kinds of stuff like this. And Blue Yonder then renamed themselves, JDA, who acquired Blue Yonder, then renamed themselves to Blue Yonder. So a bit of a confusing acquisition and renaming. But yeah, I'm of old Blue Yonder and new Blue Yonder now. So. And then finally, from an introductions perspective, what are the main steps that I think of when we're talking about moving towards a product? So first of all, we need to identify a business problem. We need to think of some way to solve that problem. And then we need to see if our solution works. So do some feasibility checks, proof of concepts, proof of values, and finally generalize it. And so that's the steps which I'll be walking through a specific example today. Okay, on to the first of those. So what's the business problem that I'll be talking about today? It is about poor inventory accuracy. So if you think of a large supermarket, a grocer, they have tens of thousands of products and hundreds of stores. And over time, their inventory just becomes inaccurate. And this is costly to them. So the quote here from this study is that about 60% of inventory records are likely to be wrong at any point in time. And they estimate that this, if they're corrected, then you could achieve 4 to 8% increase in sales. So a significant problem with a good prize to go after. So that ticks our box number one. What's a business problem? What's the cost associated to this problem? So you can lose sales because you don't realize you're out of stock of something. You can not be able to satisfy online orders because you don't have the, you don't know if you've got the stock for it, or even worse, you accept an order that you can't fulfill. There's lots of manual effort around counting the inventory. So going into the warehouses, onto the shop floor, counting everything. And lots of retailers just carry what they call just in case inventory. So they'll just add some number to their stocks of everything just in case. And this obviously can lead to higher waste for items with a shorter shelf life. And also leads to you having more money tied up in capital as well to have that stock. Yeah, there must be some solutions out there for this already, you might be thinking. So what are they? One solution is just to count more frequently. So this is costly, it's very manual, and it's disruptive to store operations as well. Having people out there blocking the shoppers. You can have hardware, robotics, imaging. It's just quite expensive and hasn't been so successful in the past. And you can, as I mentioned before, carry excess inventory, which is in itself costly. So what is our idea? Yeah, with our background in machine learning, what we thought to do is just simply treat it as a machine learning problem and predict the actual inventory. So treat the inventory as a variable that we can estimate. And so what we'll do is look at every single product location at a specific time and try and predict its inventory. So as with any machine learning problem, we've got a few data requirements. We need to have some suitable history in the data. So that means accurate knowledge of previous inventory errors. So we have to know at the point in time exactly what the inventory was and how wrong it was, how much it was wrong by. So every time somebody did a count physically in a store, you will have a data point if they recorded that correctly. And finally, we obviously need to have some data that correlates to that error. So we need something to construct features with. And does this make sense as a product? So there's a problem, we've got an idea. Is this just a project for one customer or a bespoke solution, or is this really something we want to pursue as a product? So if it was successful, it would solve a problem that we hear again and again from customers. So this is something which, yeah, isn't just one or two of our customers are saying they've got this as a problem. Most of them say that this is a significant issue. And the nice thing about it is that we are looking to correct a fairly fundamental data point in a customer's system. And from a supply chain perspective, lots of things feed downstream of what the current inventory is. So one thing it can feed into is a replenishment system. So you might want to just improve the accuracy of inventory and get better replenishment as a result. But there's anything else that uses the inventory would benefit from this. So like I mentioned before, online ordering, promising customers that the stock will be there, for example, these sorts of things it also feeds down to. It plays very nicely with our other existing products. So I mentioned a few of our products at Blue Yonder already around demand forecasting, order optimization. This would just supplement those as to make them better by improving this variable. And compared to robotics and lots more hiring and so on, it's a simple thing to implement. So the data already exists. It's just us building a model and embedding this process within their existing systems. Okay, sometimes I get a bit lost in a talk when people are moving quickly through slides. So I thought just to take a pause for a second and be very, very clear what I mean about our machine learning target. So the goal is to improve accuracy, but for an algorithm to do that, we need to be able to quantify it. So a couple of terms, first of all, counted inventory. This is the result of a physical counting process. So a man goes to a shelf, and counts one apple, that's a counted inventory. And at the same point in time, when you count the apple, you can look up on the system what the inventory is, and there are 3 items there. And so this defines our target. It's just the difference between the 2 of them. We know that the inventory was -2 at that particular point in time. And so that serves, that becomes 1 row of our training set. Okay, so we've got an idea, we've got a problem, we've got an idea, so what do we do next? So we give it a name. It's called Luminate Cognitive Inventory, something which the marketing people come up with. And how do we start? First of all, so this is our Blue Yonder strategy. I'm sure there's many ways to go about this. This is how we go about it today. I'm also not saying this is the only way, but it's a way that we found some success. So you find a customer. We've got a customer. I can't say their name right now because it's an ongoing thing, but it's a large retailer who's very keen to do this. And having a real customer right from the get-go is hugely beneficial. So they've got all the domain knowledge about what the problem really means. And then we've got real data to test it on. This is invaluable. I've seen quite a few times people develop very interesting things, but then you go out and look for a customer, and you know, the customers don't necessarily want what you've built. So you've already solved one problem if you start off with something they say they want. Then what do we do next? We build a team. So actually, different companies will go about this in different ways. I'll talk a little bit more about this point next. So we start off, we need to build a team. Then we prove the concept. So this is more like a historical backtest. We look to a live test in production. So really put it into the real world and see how it works, and then scale up. And just one note here with this, the main challenge that we face through this whole process is balancing the needs of whether it's a project or whether it's a product. And as soon as you've got a real customer, so I said this is really beneficial, but the downside of that also is then you've got somebody demanding something specific to their data. And it's very easy to quickly build a project which is just about their data and won't generalize to another customer. So I'll talk a bit more about that as we go on. Okay, the building a team part of it. So for us in Blue Yonder, a data science team, we really expect the data scientists to be software engineers. They own the products. We'll have one team per product, and they'll really own it from a machine learning perspective. We expect them to write production grade code, to deploy their own models, and to fix production issues, model-based ones, you know, not everything in the world. And we, of course, create barriers between the customer and the data science team, so they're not just getting bombarded. But we really do like to keep our data scientists, you know, involved with the real world. So we're not prototypers who pass off the code to another team to then productionize something. So that's when we have a new product that we want to develop, we build a new team, because our existing data scientists are busy on other products. Okay, let me talk a little bit about our tech stack. Just looking at the time. So the tech stack of an established Blue Yonder product, first of all. So I just take one product as an example. It's called Luminate Demand Edge. This is our demand forecasting product. What's the stack that it uses? So for management of the code, we use Git, but we use an in-house built mono repo, which we call Rack. And this is inside this, there are many different Python packages, sub-packages to it. And we built this a few years back for the purpose of sharing code more easily across different projects, across different customers. It provides with it a common development environment. So everybody will be working in the same Docker environment. And it removes the issue of having a requirements hell. If you have lots and lots of different Python packages all deployed independently, then very quickly you get into a tricky situation where they're not compatible with one another. So having it in this one mono repo with the unit tests all joined up we find is a very good way of sharing code across the different products. Also coming for free with that are some Jenkins pipelines, so you get CI/CD for free when you use this. Then for compute and storage resources, we use Azure, but we orchestrate this through a platform, again, internally developed called Stratosphere, which provides us an API and a UI, so that as a data science team, we've really got at our fingertips the ability to spin up resources very flexibly and collect resources into what we'll call a project, which are then associated to each other in a nice, neat way. So it's just a way of making it a lot more efficient way to use the Azure resources. For data management, we've got a input API that the customer delivers the data through. We've got, it goes into a database, so into Exasol, but currently in the process of migrating things to using Snowflake. And then the data scientists use what's called Kata-Tech. So this is data sets in blob storage, basically. So this lets us break the bottlenecks of the database. So it lets you access data in parallel and at scale through blob storage. From a machine learning perspective, we've got we use an algorithm called cyclic boosting, which is like a turbocharged generalized linear model. I don't have time to go into this, but Felix Wick's given some good talks on this in the past that you can find. We use MLflow for tracking experiments. We use Dask for parallelization. We've got an internal Flask API for triggering modeling jobs, and we use Airflow for scheduling. Yeah, it's hard to give a very brief overview of such a large stack, but you can see all of these. A mature product has these behind it. And so when we go to start a new product, move into the next slide, we really look to utilize as much of that as possible right from the get-go. So everything which I mentioned there on day one of starting new team, new product development, we've got all of our workflows in place around the code decided by Rack. We've got CI/CD for free. We can spin up resources straight away really easily with Azure and Stratosphere. We've got all this modeling stuff at our fingertips that we can just basically port over from our existing products. And the main thing that we don't have, because it's a new offering with different data, is we can't use this API straight away. So in this example I gave through today, we load the data from raw CSV files and we process them in memory. And this is a big mistake, I'd say already. This is what we did, but one of our learnings is maybe not to do that in the same way next time. So I'll talk more about that later. Additionally, of course, we use a lot of Jupyter notebooks here because it's a bit more exploratory as well. Okay, so finally on to the last section here. So I started calling this project development, product development, and in reality, it's some sort of a combination of the two. Days 1 to 60 is proof of concept phase. So here, what are our priorities? We need to do an exploratory data analysis, really get to grips with the data. We need to define an internal data schema for our data and make the transformation methods to take that raw CSV data that they've given us and map that into our internal schema. And yeah, this is a very important step, I'd say, when setting off with the ambition to have a product rather than a project, a bespoke project. By defining this internal data schema, you make a clear distinction that you are not wanting to build it for this one customer. Otherwise, throughout your code, you're going to have customer-specific column names, customer-specific quirks, everything just embedded in everything that you do. We also require high code quality standards, so full unit testing and as if it's production code right from the start. We process it once and put it in common blob storage. This is crucial that the whole team is working on the same data. Then next, we build a simple model, nice and quick. And then importantly, the step 4, really define a shared modeling framework for the team. So make sure that everybody is doing, that we've got the same definition of better. that if everybody's in their own notebooks and you've got different, you don't have a common evaluation framework, it's very hard to understand really, compare one person's experiment to another. Yeah, another key thing that we do here is we embed the model evaluation into the Git process. So merging to master would be blocked unless a common baseline model is explicitly updated. So what this means is we have our current best model, and for someone to improve on it, they need to update that in the code explicitly, and we as a team are all on the same page about that update. Okay, so outputs from phase, this proof of concept phase. We need to have a very good understanding of the data. So in this particular example that I'm going through today, LCI, really we could define a very simple data model, inventory and inventory adjustments. So really inventory is just telling us what was the calculated inventory known at any particular point in time. And pretty much all of the other data fits into this one simple data schema, inventory adjustments. So there we're talking about sales would be an adjustment, which subtracts from the inventory. An incoming order would be one which adds to the inventory. Incoming wastage would remove from it, and so on. So all of our data just fits into these two simple schemas. And then important model features, we've got the calculated inventory. So what is the inventory prior to our correction is obviously a very crucial input, and the amount of time since the last full count was done. So for an inventory error, you can imagine over time, this error gets larger and larger due to more occurrences of events that cause it to drift. And so this is our findings from this first phase. These two features are key. We need to have a good understanding of our target data. We've got a code base to iterate from. So when we started off this section, we have nothing. And at the end of it, we've got something to move forward from. And did we prove the concept? So now we know that we can predict something useful. What we found was we can remove the aggregate bias in the inventory. So as a whole, across aggregating across all products and locations in some time range, you can see that the inventory is out by some percentage before the correction, and afterwards we've got it nicely aligning. But in addition to that, we can improve the accuracy at the lowest level, so the MAD, by more than 20%. So this lets us move on to the next section. I see I'm running out of time here a bit, so I'm going to move a little bit faster. So great, we've proved the concept. We move into this phase here, months 3 and 4. So now we need to prove its value. So things get very technical now. So we had this nice phase where we're doing model development and we're exploring data. And now we need to productionize data pipelines. This triggers the major refactor of our code base 1. And a key point to take here is, while we are trying to make decisions from the start that we are building a product, we know that we're going to have to refactor things as we learn along the way significantly. So this is unavoidable. Performance testing, automated monitoring, model release strategy, operations, all of a sudden things get very much in this direction that we need to focus on. Okay, and then finally, the pilot. So we're ready to go live on a customer, which means that we are actually impacting their predictions on in a live setting on a daily basis. They're sending us data, we're sending them back predictions. So suddenly the game changes. You can't freely merge to your master branch anymore. Your customer is pinging you with requests for analysis and explanation, and they start to roll in. You need to do hotfix 1, 2, 3, and it feels futile to resist. Suddenly you're a project and you're scrambling to react. But in parallel to this, we've got a second stream that would go on. You have to divide the team somewhat to some extent, where you start your next major refactor. So this is to be ready for the next customers. So all of the customer specific stuff that's snuck into our code base, we need to then start refactoring out again. Even with the best intentions, these things go in. And you need to be ready to scale up to other customers, your current customer, post the pilot. So post this period here, we need to scale. So what's next on this particular example? So today we are literally here. So we're near the end of this pilot. And what we're thinking about now is, okay, we need to formalize our input-output API. And that triggers our next major refactor. So integrating the modeling workflows into Snowflake. So as I said, we went down this route of processing the data ourselves manually in Parquet files. And this is became a rabbit hole, something which we'd make a different decision from the start if we could. But to move on to the next phase, we'll be migrating it to Snowflake. And just to summarize the wins and the fails that we experienced in this last 6 months of this example I walk you through, we went from concept to production in just a few months. This was a huge win. You don't get this if this is the first development you're trying to do. So we could only do this because we were piggybacking off of our existing products and our existing platform that's in place for them. So this was a nice achievement that you can do this in that time. We form a new team. This is not to be underestimated, how hard it is to get a new team together and to come up to an efficient standard. And we got some promising early results, which I mentioned. So the MAD improvement, 20%, but there's lots to learn and lots to generalize. The biggest fails are, from a data engineering perspective, you just shouldn't, you make this decision early on, the data's small, we can deal with it in memory, and you regret it when down the line, your board is completely full of data engineering stories and performance is your bottleneck. I don't have time to go into this actually, so you can see I'm already a couple of minutes over. So just to summarize, find yourself a suitable problem. This requires industry experts. This isn't something you can just do as a data scientist. Get yourself an enthusiastic customer. Prove the concept, prove it in practice, and then really for it to be a product, you need to be able to do this about 5 more times. So nothing's a product until you've actually got several customers onto it. And the biggest learning that we've made in Blue Yonder over the years is that you need to build on your experiences, build up your platform in a way such that your next developments can immediately take advantage of all of the things that translate across products. And set out from the start if you want it to be a product with product development standards, because there's no going back from it if you don't, unless you can just start from scratch at the end and redevelop your product completely from scratch after you've done a few projects. But that's it. Sorry for running over by a couple of minutes. Thank you. Any questions?
Oh, no, yes, we've got one from Anna. How many people were working on the product, especially data scientists, machine learning engineers, and software engineers?
So we are a cross-functional team where some people do lean a little bit more in one direction or the other of those that you listed out there. But we do expect everybody to pretty much be able to do everything within the team there. But we, on this project, were project, I can never get it right, it really is both. We were 7 people over the last 6 months. So this allows some degree of parallelization between the ad hoc things that pop up and you need to hotfix and react to for your current customer, and the longer term goals of productizing and taking a step back from what you're doing day to day and actually getting ready for the next customers or further generalizing aspects of it.
All right, that was the end of the question. So thank you very much, Adam, for giving your presentation, and you and everyone else are free to engage further in our talks channel and Slack. And this is the end of the session, but we'll have a number of other ones coming up. And you all have a great day.
Thank you very much. Have a nice Friday evening.